Bonjour, mesdames et messieurs. Buenos dias, damas y caballeros. Good morning, ladies and gentlemen. My name is Sung-Hoon Kim, and I'll be your MC for this event. I'd like to welcome all of you to the International Civil Aviation Organization's 40th Assembly SkyTalks. Over a 2-week period, we have 68 presentations for you from aviation industry experts. And I would hope that you come and check out the ICAO SkyTalks channel on YouTube. This is day 7, session number 5, and we continue our presentation on the theme of innovation. To talk more about this, please welcome Marco Merens, Chief of Integrated Aviation Analyst and our AI lead. The title is Artificial Intelligence and Digital Innovation.
How do I? Sorry for this. Thank you, everybody, for being here. So I'm happy to present you what ICAO is doing relative to artificial intelligence and digital innovation. You may know that we have coming out now out of the Innovation Fair was a real big success, and artificial intelligence and what we would call digital innovation is a big part of what we do and what the industry is working on. So I want to give you a little bit of a walkthrough of 3 main components of what we would say digital innovation or transformation is artificial intelligence, digital object architecture, and blockchain. For that, you will see that I brought some objects here because I wanted to take artificial intelligence as the master theme of this. So you see, I brought here a drone. You've seen a drone. This is VR, a virtual reality kit. There's a Raspberry Pi, and a mini computer. This is my phone, okay, and this is an Amazon Alexa. So, because when you talk about artificial intelligence, a lot of people think artificial intelligence is like everything, okay. Everything you see on this table here is basically not artificial intelligence, or very, very, very little. Okay? This drone has 0 artificial intelligence. This VR equipment has 0 artificial intelligence. Even if we think this is high-tech stuff, we agree this is very high technology, but has nothing to do with artificial intelligence. It's just computers who are getting faster, computers getting smaller, and it's getting more reduced. We are getting touch screens, like my phone. Everything becomes touchscreen. So this is technology. Okay. Technology is not the same than artificial intelligence. So I would say the only equipment here which would say has some artificial intelligence side is the Amazon Alexa, and I will talk about it a little bit later. So you see here there's this technology, and we have also robots, and you would see on the internet you can have Boston Dynamics, for example. They are building robots who are walking like humans. Again, 0 artificial intelligence inside. These are just mechanical, really precision machines, okay, related to computers, and everything gets faster and smaller, so that's what makes this happen. The problem is that artificial intelligence is mainly invisible. It's like our own intelligence. AlphaGo, that's an example of artificial intelligence. So it's the computer who beat the master in Go, which is, I would say, the game which is the most complicated game humans play. And so AlphaGo is an artificial intelligence who has taught itself how to play this game by playing against itself, just with the basic rules of how to do the moves. So it taught himself playing billions of games against itself, and after a while, so was able to beat anybody. That's artificial intelligence. Another example of artificial intelligence is facial recognition. Yeah. You see, it's when we replace the human. So artificial intelligence is something invisible where we replace a judgment of a human. So here's the machine recognizes the person with the ID card the person puts in, and the machine actually confirms that the image of the card is the same than a human in front of it. Where normally you would need to put an officer there checking the card, looking at the person and deciding, yes, the person I see is the same than on the photo. Machine can do that. That's artificial intelligence. But see, it's not this box. Okay? It's basically the computer behind or the model. So to demystify this a bit, okay? So this invisible, basically artificial intelligence is visible, and it's not these objects. Just to explain you a little bit how it works, I think it's important, again, with the idea of demystifying it. Because artificial intelligence is around since the 60s. In the 60s, these mathematical models were built. So this is a simple mathematical model of on a representation of how our brain works. Okay? All these little balls are supposed to represent the neurons in our brain. And they are connected to each other by these lines, you see. And these lines, the biologists call them synapses. And so they relate the neurons to each other. And so this is a mathematical representation of this. So in a computer, we call this a neural network. So artificial intelligence model is this. It's basically a function which takes an input and an output. The input is what you see, the layer on the left. All these lines of neurons, we call them layers. On the left, you see six neurons. These are like the inputs. You know, it's like a function. You calculate something. And on the right side, you see four, what we say, outputs. It's the neurons which we are calculating. So all of this is basically only numbers. Each of these lines represents a number. And if this function, for example, does some calculation, so for some input gives an output, we say that we train the neural network. So we don't say we program it, we say we train it. Training means that I have to find the numbers which are associated with each of these lines, so that's my input produces the desired output. It's as simple as that. There are only multiplications and additions here. It's like a 12-year-old could do this. So the complication comes from when the size is going up. So if here by hand someone could calculate this with 6 inputs and 4 outputs, in the real world, when I want to do facial recognition, I have probably 200,000 inputs and outputs. So, and I have layers which can have hundreds of thousands of these neurons. So this is becoming huge. Okay? So that's why in the 60s, when they invented this, they were unable to solve that problem because they did not have any computer was doing this. So they were doing this by hand. So we had to wait until like recently, where the computers became powerful to solve these simple mathematical equations, but just because of so large, to solve them in a reasonable time. We could not wait for a week to calculate these, what we call weights. Weights is the name of the variables of the lines there. We cannot wait a week to do this. So now the computers are powerful, so we are able to solve this like in an hour or even 10 minutes. Okay? So now it becomes usable. And so it's not that artificial intelligence was like invented like last year or something. You know, it has always been there. But it's only because the computer is getting so powerful that now we're able to do this nicely. So basically, an artificial intelligence learns by humans showing him examples of things. This is like an example of what we could teach in artificial intelligence, like to recognize animals. Yeah? So we would just, because everything is like numbers at the end. Okay, this is an image, but an image is like pixels. You know, so I have maybe 1,000 pixels horizontally and 700 vertically. So it's a number of few million pixels, which are all numbers. So I can put them as an input to my neural network, and then just the output would be 2 things. Is it a dog or is it a cat? And I would present millions and millions of images like that to my machine, and my machine will be able to understand. And we really use the word understand. Okay? It really gets it, because you will not be able to program in Python or in any other programming language what is the difference, what makes a dog and a cat. Okay? You cannot mathematically define this. It's impossible. As humans, we see it. And I mean, the kids, that's how we teach the kids. You know, we show them pictures, a cat, and then the baby says, this is a cat, and then they get it. It's the same thing. It's through learning, seeing examples, and a human saying, this is that. Now, what's the interesting part with the AI is that we say, yes, the AI has actually understood what's the difference and how to distinguish a cat and a dog. And it can actually generate new ones. Okay? That's getting interesting then. You may see now, you see these pictures here, the dog and then the cat next to it and the cat next to it, they look like similar, okay? These are fake pictures, okay? So the AI has taken the first picture of the dog, then transforms it into a cat, okay? These do not exist, okay? Means that the AI has really understood what makes a dog and a cat, and can replace them, and can actually build new things. It will make pictures which do not exist, because it just got it, okay? And people are using this now, for example, shoes designing. It goes back into the creation mode of how humans, we are creating things, okay? If the AI starts to understand how we design shoes, by having looked at shoes, like millions of pictures of shoes, it will just design a new shoe, a different one, someone which did not exist. And you look at it, and we would say, yes, it could have been designed by a human. Okay? So the creation part, we have to really look at ourselves and see how are we going to create new things, because the AI has visibly understood how we are designing shoes, how are we designing clothes, what is our role within that system. Okay? So I think that's something we will need to, we need to understand, and we need to define for ourselves. So typically the AI is used to associate various things. The AI is able to associate an image to some text. That's what I just showed you. It's associating a dog with the word, a picture of the dog with the word dog. Okay? So it's associating pictures with text, all through data. Yeah? Picture is transformed into numbers, the text is transformed into a number, which is basically already kind of a code. And then the AI makes this association. Same between speech and text. Okay? So that is actually the powerful thing of this of Amazon Alexa, is that when you speak something, you say something, is your voice is translated into text, which is then processed and then transformed back into the speech. Okay? So the AI, the component of Alexa, is the speech to text. That's the AI thing here. Okay? That's almost impossible to program using normal language. The other way around, from text to speech, that's easier. Like your GPS, the GPS you have in your car, the GPS talks to you, but you cannot talk to the GPS. Okay? If I try sometimes, that does not work. Okay? So the GPS talks to you, but that's no AI there. It's normal programming, because it's text to speech is easier. But the other way around, it's very, very complicated. You cannot program that. Or if you try, it's really you fail this. So that's what AI is, and so AI is in here. What is put, for example, in a drone could be the camera of the drone, which sees something and then transforms that into a message, what it sees. Okay, but that would then be inside the camera, not the flying of the drone. Okay, the flying of the drone has no AI or whatsoever. Yeah. But then the camera, because we're going back to see, so it's, you see, the AI is basically that text, speech, or image, okay? And the interpretation of that. Going back into the aviation mode, so I've said that we're able to teach an AI to recognize objects. Okay, so the AI is also able to recognize the objects within an image, multiple ones. Okay, so here this is a camera, and so we have AI models which were trained to recognize a car, make a difference between a car and a person. Okay, so you see, like the blue is like objects, like mechanical objects, and then the blues would be a person. So it makes a difference between a person and an object. So it's a model where we have given images of people and images of objects and told the AI, this is a person, this is an object. And then it's able to look at it and then classify them. So here it was able to recognize three things, basically the aircraft and the other objects. So you can teach anything to the AI related to recognizing this. But if you think about it, it's not really useful as such. Okay, what is the advantage by an AI seeing that there's a car versus me seeing there's a car as well? Okay? The thing is for me to say, what car is this? Okay, because I maybe have 200 cars, and I want to know which one is this. Okay, or I want to track my cars, and I want to know which one is where. So there's a notion of a database. I have a database of all my cars. It's stored somewhere. Okay, who's driving them and how old they are, their maintenance records. So I have a database of my objects, cars, and I have the AI, which makes me the link between my image and inside the database saying it's this object I see. Okay, so you see there's a link between the object, the AI helping me identify the object. That's where we're getting to the second big part of digital innovation, which are digital objects. Okay? And a core component is what we would call a digital twin of something. Okay? So we have a physical world object, which is an airplane, which I can see fly in the sky, and I have a digital twin of that object. A digital twin would be an entry in a database which contains all the information about that object. How old it is, the maintenance records, the parts which are installed on it, and any other information you can have. So if I manipulated the real one, it's exactly the same as this digital twin. You can imagine that my passport, if I have my passport information is supposed to be a digital twin of me, kind of. Yeah? If I go to the customs and they check my passport, they will see, okay, this is me. So the information about myself, it's like a digital twin of myself. Okay? Another thing is that if you have your phone and you do regular backups of your phone, well, you have a backup. The storage of the backup of your phone is the digital twin of your phone. Okay? So you can take that, put on any other one, it's exactly the same. You know? So there's this notion of digital twins. So in the world of the data, we would call this digital objects and digital object architecture. Okay? In the world of connected objects, each of the objects should have a digital twin somewhere. Okay? And we have a digital twin for this one, we have a digital twin for that. You saw the passport problem was already solved. Passports, we have a unique place. If I go to China, my passport is scanned, gives me some information. If I go to the United States, it's the same information. Yeah. It's not different. It's the same. So me as a digital object, I'm unique. Okay. That's complicated. Okay. The passport world, they have solved that, but it's very complicated. It was very expensive. Yeah. But imagine you try to build that for every object. You need to find other solutions. And that's all the domain of digital objects and digital object architectures. Finding a way to uniquely identify something and make sure it's unique. Not that you have a digital twin and somewhere else you have another one. Okay. Going back to that, there's the third, I would say it's the third component. How am I sure that this digital twin I have here is the right one? Okay. How am I sure about that? How can I trust that what I see here is right? How the community is going through this is generally through encryption. So I must be trusting in two things. That one, this is the correct one. So the digital objects can maybe have an ID. There's a notion of ID, which is important. But then the trust on it means that I must be sure that nobody connected to this thing and changed stuff. Okay? So this goes through some sort of encryption, right? And that's where we're getting into the third big technology. It is just blockchain. Okay? Blockchain is supposed to take objects like that and like connect them together. Okay? They're connected, they are isolated, they are encrypted, and all the different versions of the objects are tracked. Okay? imagine your airplane. Your airplane can be one of these boxes there today. Tomorrow you change a part in the engine or somewhere in the airplane. Well, your digital object has changed. It's a different version of it. Well, you must be sure that that was done correctly by the correct persons and that it's not going to be changed and that's the security around it and everything. So it actually changed from one object to the next, like in this image, it would change around. So this is what we would say the technology of blockchain. It's a database which has different versions and which are encrypted, highly automated, highly supervised. It's used today by the Bitcoin to manage the currency. So all the transactions, when you buy something or exchange Bitcoins, every transaction is what we call logged in a blockchain. It's secured, it's stamped, nobody can go and touch it, nobody can change it. If someone would change it, the whole world would know it and the system would actually flag it. It's the same for if you would replace the Bitcoin or an account by the airplane. When someone modifies the airplane status, it would be done through blockchain, and it would be encrypted and tracked and traced, and it would be totally immutable forever. Okay. So you see, these are basically the three main technologies we would see now. Okay. It's artificial intelligence using data, massive data to train its models, and then pointing to objects which are digital objects. So then we have everything related to digital object architectures, the management of IDs. How am I giving IDs to all these objects in the world? It's a subject on its own. It's called digital object architectures. And then how do I trust these things? How can I make sure nobody touched it, nobody changed anything without me knowing who's the owner of that? And where is it stored? Is it encrypted and all? That's blockchain. So I hope I gave you some introduction on this. These are all kind of big domains in research, and applications are coming very fast. You see, if we do this again in 3 years and we put things on this table here, there will be probably other things where I would say, you know, we see all of these objects. Well, there's AI in all of them. Okay, not like today where I would say it's not, but that's definitely the future. And maybe all of us, we will have our digital twins standing here next to me, and then we'll have a discussion with my avatar or something. So yeah, thanks you for listening, and if you have questions, feel free.
Should anybody have questions, I would invite you to step up to the mic. Thank you, Marco.
Thank you.
Okay.